You have to know that carbon is a unique element to chemists. The question is why? Carbon is the center atom in organic compounds. It forms many ordinary covalent bonds. It can be single, double, triple bonds with other atoms and including self. There is something more about the covalent bonding of carbon atoms. Carbon atoms can bond with other carbon atoms to form long chains. Silicon can do the same, but not as strong as that seen in carbon-to-carbon chains. This ability of elements being able to bond with themselves to form long chain is called catenation. Catenation gave rise to numerous carbon compounds. This is the reason chemists are eager to study these carbon compounds that are mostly nature-like. I promised us in the previous lesson that we will explore why carbon is a very special and important element in chemistry study. 1. Carbon has 4 valence electrons. This is perfect for covalent bonding. Carbon's electron configuration is 1s22s22p2 at ground level electron configuration. But it is 1s22s12p3 in its excited state, meaning it has 4 valence electrons from the ground and excited states. There is something unique about this. At ground state, it has 1 lone pair. I mean this 2 electrons with opposite spins in 2s2. It has 2 unpaired electrons. The 2 unpaired electrons are located at 2p orbitals. This and this. Carbon and carbon monoxide, also known as carbon-2 oxide, bond with this ground state electron configuration in both ordinary covalent and coordinate covalent bond. You can see it here. But the major covalent bonding of carbon are seen in the excited electron configuration state. It can form single, double, or triple bonds using hybrids of sp, sp2, sp3. This is from the 4 valence unpaired electrons, unlike the 4 valence electrons in the ground state. The 4 valence electrons are this in 2s orbital and these 3 electrons in the px, py, and pz. This 4 valence electron allows carbon to form 4 covalent bonds, creating a wide variety of molecules. These single, double, or triple bonds gives carbon incredible flexibility in bonding. 2. Carbon can form strong and stable bonds. Carbon-to-carbon bonds are strong because of their small atomic size. This strength allows carbon to create long chains and rings that are stable but also reactive enough for biochemical processes. 3. Carbon shows catenation, the ability to bond with itself, forming a long chain. Carbon is one of the few elements that can bond with itself in long chains, branched structures, and rings. This property, called catenation, leads to the enormous variety of organic compounds. One carbon atom can bond with 4 other carbon atoms, can bond with 3 other atoms, and can bond with 2 other atoms. Other elements like silicon can catenate, but their bonds are much weaker than carbon's, due to them having higher atomic size. 4. Carbon can form different hybridizations. Carbon can rearrange its orbitals to form sp3, sp2, and sp hybridization, allowing for different molecular structures. sp3 hybridization is tetrahedral in shape. That is, carbon to carbon, all single bonds, example, methane, CH4. Ethane, C2H6. sp2 hybridization. It is trigonal planar in shape. Double bonds, example is in ethene, C2H4. sp hybridization, it is linear in shape. Triple bonds, example, ethene, C2H2. 5. Carbon compounds show isomerism. Same formula, different structures. Carbon can be arranged in different ways to form isomers. This is as a result of catenation, branching, repositioning. This is why millions of organic compounds exist even with the same molecular formula. They can have different physical and chemical properties. 6. Carbon forms a vast range of organic compounds. Carbon's ability to bond with elements like hydrogen, oxygen, nitrogen, sulfur, and halogens results in millions of organic compounds. The position of those atoms may differ, yielding to different compounds. This is why organic chemistry is a huge field of study. It includes everything from simple hydrocarbons to complex biomolecules like DNA and proteins. 7. Carbon is essential for life. Carbon forms the basis of all biological molecules, carbohydrates, proteins, lipids, and nucleic acids, DNA and RNA. Life on Earth depends on carbon's ability to form stable yet reactive molecules. Carbon is special because it has a small atomic size, it is strong, versatile, and abundant. It forms the basis of organic chemistry and life itself. Its ability to bond in diverse ways allows for an endless variety of molecules, from the fuels we burn to the DNA in our cells. This is why carbon is the king of chemistry. In our next lesson, we will look into terminologies in organic chemistry.